So you are going to go in and design a decoder for a 7-segment display. You are going to create your VHDL and you're going to download it onto a programmable logic device. Okay? This is the programmable logic device that you will be using, and it is an Altera DE. Boy, that's blue on blue, isn't it? Let's do that. But then you can't see my book, though, so let's do this. Let's see. Maybe something like that. That's fine. There we go. All right, so this thing right here is a programmable logic device. It's called the DE0CV. The big chip on here is called an FPGA. We don't even know what that means yet. That's in chapter 11 or 12. But you can think of it as it's just a chip that has hundreds of thousands of logic gates. And when you hit synthesize on the tool, it is going to take your VHDL, create the gates for you, and download it onto this chip. And then you can run stuff. Okay? Notice that when we use Model Sim, we are only simulating. Okay? When you use this, you are synthesizing. Now, the labs in general, going up until about the computer lab, you don't necessarily need to simulate them, so you can spend your time just synthesizing, even though in the real world you would usually simulate it and get it working, then you would synthesize it. But these are simple enough that you can skip the simulation step. So when you download your program onto this, it's loaded onto this blue board called the DE0CV evaluation board. It already has a bunch of I/O connected up to the FPGA. Okay? So you'll notice down here you're going to see 7-segment displays, you're going to see dip switches, you're going to see buttons, you're going to see I/O headers, and these are all wired up to the FPGA already. Okay? So what you need to know when you download your design is when you synthesize and download, you're also going to assign the pins for the various I/O that are on here. Now the pinout location is all given to you in a user's manual for this board, which is on the course website. Okay? Now this board is powered by USB. Okay? It is a board that does have the ability to receive external power, but you don't need it. Okay? Everything that we do in here can be powered off of USB 1. Okay? So USB 1 is 5 volts, and it'll give you 400 milliamps, so it's 2 watts. Everything we do in here is fine. So you never need to plug this into the DC power adapter, so you just plug it in with your USB cable, and you're off and running. Let's go down and talk about today's lab. So the lab is written as if you've never used the software before. You'll remember the first lab where we use the FPGA, I just walked you through, like, here's how you start the software, here's how you start a project, save it, do this, 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 and this, and I walked you through everything. I do that again in this chapter, just assuming that maybe you haven't used the software to synthesize. The software you will be using is called Quartus. Now, when we downloaded the Quartus thing, the Quartus bundle, it had 2 programs. It had Quartus and it had Model Sim. So Quartus is the name of the bundle. You got Quartus and Model Sim. Model Sim is what we use to simulate our homework. Quartus is what we use to synthesize our designs. Okay? All right, so you're going to come in here and you're going to read this beautiful text. The objective is to begin modeling combinational logic using a VHDL process and combinational programming constructs. You are going to make a 7-segment display. Okay? Now, it's going to come through. You ever wonder why we do all this stuff? Yeah, me neither. It's to learn something, right? So I have learning outcomes on here. So if you're ever curious why I'm having you do what you're doing, it's not just because we had some time to kill. It's because I wanted you to learn specific things, okay? Now, in here you'll also see parts needed. Every lab you will do in this course requires this board. Almost every one of them just requires this board. There are a couple labs that will require you to use this portable oscilloscope, which is called an analog discovery. So if you were in a situation where you had one of these, you could just come to lab and use the analog discovery. But for this one today, you're just going to use the FPGA board. Okay? What you will be doing is demonstrating a VHDL design on an FPGA that drives the hex 0 7-segment display using the slider switches. Okay? So that is a demo. You're going to get it working, and what you're going to do is you're going to come along and you will you will come into here and you will use these slider switches and you will put in a 4-bit binary code. If you notice, you'll get familiar to what everything's called on here, but you'll notice that each of these 7-segment displays are labeled something. So you see how it says hex 0 right here? That's the hex 0 display. And it's 7 LEDs connected in a character display format. You will read in inputs from these 4 switches down here, which are called switch 0 to 3. You will drive them to the red LEDs, which are these little guys right there, and you will display the decimal character on the character display. That's the entire lab. Okay? So that demonstration is 90% of your grade. You will also provide your top.VHD, which is your actual design, as 10% of your grade. Okay? So if you look at this, you go through, I give you a block diagram of how it's connected. This blue is the FPGA. It's important to note that this board has an FPGA plus stuff. The plus stuff is already there, cannot be changed. You just need to know where that plus stuff is, where it's wired to. All you get to do is put code on the FPGA, okay? The programmable device. Your VHDL will always be called top.VHD. That's the common naming convention for a real synthesizable design that goes at the top level, meaning top as in its ports are the real world. So the ports that come out of that FPGA are going to drive LEDs. They're going to drive connectors. They're going to receive buttons. They're going to receive slider switches. So those ports are real. That's not to say you couldn't have a subsystem inside of it, but just think of top as you are the top of that FPGA and you're talking to the real world. Okay? So of course I draw you a picture to show you kind of what's going on. I even went so far as I gave you the pin numbers of where these are connected. So here's your slider switches. You're driving the hex displays. You're driving LEDs. You're feeling so good. I even took a picture and circled them for you, just in case you didn't know where they were. Okay? Now, I even drew you out a table. Okay? Boy, I must have been feeling like you guys couldn't handle this on your own, huh? Don't worry about it. I believe in you. Now, here's the thing with these LEDs. They are common anode, meaning that the LEDs are wired in the 7-segment displays such that the top anode is wired to the power supply. Then every LED, it goes out to every LED, and then every LED is connected to the user input. Meaning, if you want to turn it on, you got to put a 0 down here so that you get a power supply drop across your LED and on. So a 0 equals on. Okay, that's what it means. So you have to fill out a table here, which is, you know, basically negative logic. It's exactly the opposite of what you might think. But all you got to do in here is anytime you want a LED to come on, you do a 0 for that particular output. You fill in this table. Okay, that's your design on pen and paper. Then I walk you through everything. Install the Quartus Lite software, if not already installed on your computer. Okay, this is as if you haven't installed it. And then I walk you through. Start it. Create a new project. Name it this. Next. Everything. Everything. Too much. Too much. Then I even tell you how to create the top VHD. I tell you to add this library. You are moving into, you're doing something on your homework and in this lab that will be the only time it happens. I'm asking you to use a package called Standard Logic that we haven't covered yet. I tell you, enter the VHDL entity. I even did a screenshot of it. This is ridiculous. Then compile, synthesize, assign the pins, download it, bada bing. What we're going to have you do is take short videos as demonstration videos and upload them to the assignment Dropbox. So the idea here is that you whip out your phone and you take a 2 to 3 second video of your project. Okay? So you should be able to, you might take 2 people to do it, but someone holds the phone and you just go 3 seconds. Why do I only want 3 seconds? Maybe 5 seconds, but why do I want such a short one? Yeah, I don't want a big file, so try to make the video short. All right, well, good luck on that lab today. You are doing lab 8.1.